All right, geometry. This is 1.3. We're just going to do about half of the lesson for 1.3, and then we'll do the other half in class. So hopefully that works for you. I just want to get some of the note taking done. Hopefully a little bit of this is review. You should have probably done a little bit of this in algebra at some point. If you didn't, no worries. We can work through it, but we're doing distance formula, and there's two different ones. So I'm going to share my screen. We'll take a little notes, and then I will, because of the distance formula, the other one is a little more writing. I'll stop the share of the screen and go to the whiteboard here, and we'll try that. I haven't done a ton of the whiteboard, but hey, we can learn together. We can figure it out together, okay? So this is a distance formula for a number line. This is pretty straightforward, okay? I'd still write this down, maybe box it, underline it, highlight it. Nice little formula here. So the distance between 2 points is the absolute value of the difference between their coordinates. Okay, so if P has coordinate x1 and X has coordinate x2, PQ, the length of that segment, is equal to the absolute value of x2 minus x1, or the absolute value of x1 minus x2. So when we're talking about distance, it's important to note that distance does not have a direction, okay? It can have a direction. I mean, in the sense that maybe you're going north or south, but in terms of math, okay, distance doesn't have a direction. It is a length, it is an amount, and it usually, like 99% of the time, is positive, okay? So distance, you want to think of it as a positive number. So that's why they're doing absolute value. It doesn't matter if you start with P and then subtract the x1, x2. Distance is going to be positive, okay? So just have that in mind as you subtract. Okay, so let's do an example here. And if you need to pause and write a little more of that down or whatever, you're free to do that. Okay, so use the distance formula for the number lines to find each measure. Okay, so we're going to find 2 here. So you can watch me do the first one, and then maybe you try the second one on your own. So we're talking about CD. Okay, so it looks like C is -4 and D is -1. Also, another reason to use the absolute value is because we might be dealing with negatives, okay? So for example, for CD, we're gonna do -4, and you can do it the other way. I'm gonna start with the C value minus a -1. Okay, that's gonna be our amount, and we're going to take the absolute value of that because we want a nice positive number, okay? So -4 minus a -1 becomes -4 plus 1 minus a negative becomes positive. Okay, and that gives us the absolute value of -3. It's a nice 3. Look at that. Come on. Okay, and so that equals 3. Remember, just a quick reminder, absolute value turns everything positive. If it was already positive, it stays positive. If it was negative, it becomes positive, okay? All right, so why don't you pause it, try DF real quick, just make sure you get the same thing that I do. And now I'll show you and you can check your answer. So for DF, we get -1 minus a +2 this time. Okay, and we're going to take the absolute value of that. And so that's going to give us the absolute value of -3, which is again 3. Okay, and you can double check yourself. If you're like, am I getting this right? Let's count just from C to D. 1, 2, 3. We got 3. D to F. 1, 2. Oh, did I mess that up? 1, 2. Oh, I did. Sorry, F was 3. You guys, you need to tell me that. Come on, guys. Sorry, I was looking at 2. F is not 2. Sorry, hold on, okay. See, we all make mistakes, all good. Okay, so let's go back here and we'll just fix that. So f is 3. I thought it funny that they both come out to the same thing. So f is 3. So we're going to do -1 minus 3. So hopefully you did this on your own and you were like, Mr. Turner's making a mistake. So then we'd get the absolute value of -4. And then our answer is 4. Okay, cool. So then you could count that again. Now I'm going to count it right. 1, 2, 3, 4. So we got the same thing. Okay. So that is absolute value on a number line. That's not hopefully earth-shattering there. Let me clear that. So if you need that, pause it now, clear that. And then let's look at this. So now we're talking about a coordinate plane. We're looking at distance on a coordinate plane, okay? So there's some amount, you know, that we're gonna go up, and then there's some amount that we're gonna go over. But we wanna find the distance of this line, okay? So in this case, what we wanna break out, I mean, you could do Pythagorean theorem, right? This would be our c squared. Okay, and then we'd have a squared, b squared. You could do that. You could count how many you go up and how many go over, and then you could put in the Pythagorean theorem. You could definitely do that. Or what we're gonna use here, and this is important to start getting this down. Pythagorean theorem, of course, we're gonna use for other stuff too, but we're also gonna use the distance formula for other stuff. So hopefully you guys remember this guy. Hopefully you got some of it in algebra. But let's say we have a point PQ, that's x1, y1, and we have another point Q. I'm sorry, the segments PQ, our first point is P, it's x1, y1, Q is x2, y2. This would be our distance formula. x2 minus x1 plus y2 minus y1. Okay, both of those quantities squared, then added together, then square rooted. Now, a quick reminder, you can't, you know, if you end up with something like 9 plus 25, a reminder that you can't square root them separately and then add them. You need to add them first and then you can square root them. Okay, and don't forget you got to square them. Okay, and we're going to do an example here. So that's your formula. Make sure you have that written down too. We will definitely use that more than just here. Okay, so I'm going to do one example for you, and then that'll be it here. So we're going to use the distance formula to find the coordinate planes. For coordinate planes, to find the distance from this point, -4, 2, to 0, 8. Okay, now I'm going to switch over and do it on the whiteboard so that I can write a little better than using my mouse here on the screen. That's a little slow. So I wrote down the points and I'll write them down again. So let's switch over here to the whiteboard. And again, this is like, I haven't used this a ton, so you just, you bear with me here, okay? So we're going from -4, 2 to, ooh, that's a tough 2. See if we can change that real quick. Again, just be patient. Over to 0, 8. Okay? So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, now again, when you guys were doing slope 2, the x2, y2, it doesn't matter exactly which one you denote as your x2 and y2, but you just got to keep it consistent. So if you choose this as your second point, then you got to use that as your x2. You could choose this as your second point, but you got to use both the y and the x as the second, okay? But let's just do it normally. So we're going to go 0, 8. So is our second point. So we're going to say this is x2 and y2. Okay, so it's going to be the square root of 0 minus the negative 4 squared, the whole thing squared, plus our y2 is going to be 8 minus 2 whole thing squared. Okay, so that gives us, if we minus a negative 4, that gives us a positive 4. So we get 4 squared plus 8 minus 2 is 6, 6 squared. So in our square root, I'm going to move up to the right here. We're going to get 16 plus 36. Okay, and if we add that together, what does that give us? 52? Is that right? Square root of 52. I don't think that's a nice square. So one thing we're going to talk about doing later, that'll be our answer for now, but we're going to talk about estimating square roots. So we know this square root is somewhere in between. What are we talking? What does that give us? 7 and 8, and it's definitely closer to 7. So maybe you'd say this is approximately 7.2. I don't know. We can test it on a calculator and see if I'm close, or you can. Sorry, that's a bad point. I'm gonna fix that. Oh, try to get the eraser going. Okay, so that would be your answer. Okay, 7.2. And that's how you'd use the distance formula. Nice, good work. Maybe I have you try one on your own, huh? Let's see if we can find one in that other slide here. And then I can do one more so you can check your work. Let's just take the one we had earlier. We had A was 2, 1, and B was 6, 4. Okay, so here we go. I'm going to share it again. A is 2, 1, B is 6, 4. So once I write this down, so we have A, this was the one on the graph that we just kind of looked at. A was 2, 1, okay, and B is 6, 4. Let's find that length. Okay, so now's a good time if you want to pause it, try it on your own, and then you can check back with me. When I do these ones, I'll probably go a little faster because hopefully you're just kind of checking your own work. So we're going to have the square root of our x2 is going to be 6 minus 2 squared plus 4 minus 1 squared. Okay, so that's going to give us the square root of another 4 squared, which we had in the last one. Oh, it's a tough squared there. Plus 3 squared. Okay, so that's going to give us the square root of 16 plus 9. Okay, so if I continue on the right side here, that gives us the square root of 25, and this one comes out nice. Now, it is true that the square root of 25 gives us a -5 and a +5. But remember, we're talking about distance here. So really the only one we care about, distance is positive. So really the only one we care about is the +5. It is true in other applications of algebra that we will care about this -5 answer, but most of the time, again, like 95 to 99% of the time in geometry, we really only care about the positive answer in some of these algebraic things because we're talking about lengths and distances and shapes, and negative distance doesn't make as much sense. Okay, so hopefully you got -5, and we will do more of these practicing together in the class. So I'm going to clear that. I'm going to stop the share. And I'm hoping you guys have a good rest of your night, and got any questions? Just let me know. Thanks.